Mr. Minnick here, helping my students with the advanced drawing project here at YMissing in the year 2018. Now here's a demo program that we are currently looking at that helps you learn a bunch of things, including functions as well as loops. So here goes. When we run this little Python program, it does this over here that you see on the right, a bunch of blue squares, a big black square, and a big blue square. So first observe that in this Trinket, I should say, in this Python program, this code, notice that I have at the top some imports so that I can use Turtle Graphics, and I generate a random number or two a little bit later, so I need to import random. And then I set up my screen. I don't have a fancy background graphic or anything like that that would normally go in this setup area. But I do use this command pen.tracer00 that, along with the update function, along with the update function that's being used down here, pen.update, it makes this really draw fast, faster than .speed 0 would be. So if you want to save time while you're working on a project, do the old .tracer00.update trick to make it speed up. If you want it to show slowly, then I guess take those away and change the .speed of the turtle. Anyway, now let's look at the real code. I put these things called functions up at the top, a whole little area in this comment hashtag area where it's all DEF functions, which at Trinket, you can kind of shrink and look at the body of the function, the code that's indented inside, or you can shrink it up. We always put a nice little comment above a function's header. The first line of a function is called its header, and the description describes what the function does. Now sometimes functions are quite complicated, and the name that we give, say, to a function like draw star isn't enough to get it across. So if you have to say something like draw a star and move the turtle to the right edge, you would say that in a longer way there, but you would still keep the name of the function nice and short. By the way, functions, when they're named, they should start with a lowercase first letter, just like any variable, such as the variable pen here. And if it does have a second word packed in together, you're not allowed to use a space, but you should capitalize that next word just to make it more readable. I always like to name my functions with a verb in it, because the purpose of a function is to do something, like draw star, clear screen, move cursor, check for wind detection, stuff like that. Now that's not a law that says you have to put a verb in there, but it's just good style. Okay, so look at this function draw star. No, don't look at it. The whole point sometimes of functions is we don't need to look inside the function, just like I don't look at my car's engine every day. I just keep the function, the hood of the car down so that the engine is hidden, and I just trust that it works. So look at this. The hood of the car is closed. I can't see the engine that's inside of draw star, but if you ever want to pop the hood and check the oil, you can still do that and change like that 50 to say 60. But normally we don't have to look at it. We just trust that it works as advertised. Did you know that import turtle, within turtle, turtle's just a file that has lots of functions. And that's all random is. Random is a file, a module technically, with a lot of functions. Okay, so where is the real code that does something? Well, it's all in what I call the main program here, which is basically the rest of this. So now let's trace through the main program. This section right here, as I point out, it makes a black square, this black square that you see, it just does it the way we learned like a month or two ago. How annoying. Pen.forward, pen left 90, I turn left 90 degrees. Go to this, move right. How annoying. Don't you appreciate the fact that using this new thing that we're studying called a for loop, that in these 4 lines of code here, I'm doing the same thing, but with the color blue squares that I did with all this redundant code up here where I made black squares. So this black square and this blue square are made differently. The black square is done manually with brute force, I call it. But the blue square right here, after I change the color to blue, look, it's a nice little for loop that you can even shrink up like the hood of a car and not look at it. And that for just shows that the code repeats 4 times inside there, making the 4 sides of the square. So I could change this to a hexagon or a pentagon or something very easily. There's another video, I think, for that. So that's not using any functions up above, but it's just using a loop. Let's prove it by commenting out the whole program from line 42 down to line 64. So I'm taking out of play, kind of like a soccer player that is, a hockey player that's in the penalty box. Sorry, all you red lines of code, you're in the penalty box. You can't play hockey for the next couple minutes. So now I'm going to run the trinket, and look, it's only this lonely black square because only this brute force code is making the black square. But now I'm going to comment out the black square by doing the little triple apostrophe thing, so that in between those apostrophes, that code is in the penalty box, which means I have to take away the 3 little apostrophes there. Now when I run this trinket, this Python script, I'm not getting the black square because it's like out. And I'm done making that point in this video that it was brute force. We don't do things like that anymore in this course. Why do something with brute force when you can just do it with a nice little for loop? Yeah, good question. So now we have this better blue square. That's the big blue square. Now, just because I don't want stuff to be on top of each other, I move. Oh, I don't really need to move myself to the negative 150, 150. Yeah, I do. So just trust me that that's needed. Now let's look at lines 57 through 61. Oh, it's another for loop. This one also executes Seamus knows 5 times because the number 5 is there. Oh, this was 4. But look, inside the body of this loop, this line of code number 59 is what we call a call statement. That's a call statement that calls into action a function. So the function draw square has already been defined and advertised way up here in the functions area. Draw square is there, and we just trust that it works. So I'm not even going to look at it any closer. Just know that one square gets drawn within a for loop that Seamus knows iterates, goes around 5 times. So somewhere we have 5 squares, but I don't know which ones are the 5. So you know what? I'm going to change the pen color here. Pen color. Braden, what's your favorite color? Lime green. Okay, whatever. So I didn't want lime green everywhere. So I guess I have to change it back to some other color right after that section. So sorry about this change. What's your second favorite color, Braden? Teal. I hope that's spelled right. Well, that looks like lime green. So orange we will go with. So see the green squares? Those are the ones, the lime green squares are the ones that are drawn with Seamus's iterates 5 times loop. But there's one call statement. So you say you want 50 squares, 50 green ones, just change that 5 to 50. Check it out. Oh, they go off the screen because I had moved 50 pixels in between each pair of squares. If you trace this code, after drawing one square, it moves forward and then draws another square, moves forward, draws another square, and I don't have time to explain it 50 times. Let's change it back to 5. If you want to change this to stars, check it out. Call Domino's if you don't like Papa John's. It's a function. Pizza joints are just functions that you call. Call statement, call. So check this out. Now I have stars that are lime green because I changed the call statement, draw square. I want draw oval. I'm going to change that to draw oval. Check it out. Uh-oh. Okay, we're pausing this video. So I just realized that up here in the functions area, I don't have a function called draw oval. So that's why right now draw oval and that's why draw Robbie's forehead don't work, because I don't have that function yet. I could go make it, but there was a draw star, so I'm going to put it back to draw star. Okay, it's working again. Stars. Now let's look at the orange area of the code. Now here is one call statement, and it's not even in a loop. Why am I getting 30 squares? Here's why. Because the function draw many squares has a loop within it that you don't see there. And the loop within it does a for I in range 30. You say you don't want 30 squares? You only want, say, 3? Check it out. I'm going to run. Now there's only 3 orange squares. You say you want -3? I have no idea what's going to happen here, -3. Okay, nothing comes out because, well, -3 is less than 0. So I didn't mean to really do that. Let's put it back to like a moderate amount, 10. So let's trace this and see why it works the way it does. When you call Domino's and you say you want 30 pizzas, that means you fly up the screen, well, like a bird up here. You know, we're coming up here to the function called draw many squares. And this has got to be spelled the same. Draw many squares is spelled the same way as the DEF header, draw many squares. Capitalization counts, by the way. And the num, the variable num here, it's called a parameter. The parameter num matches up with the 10 that I have here. It just plugs in a 10 to this num. And now, Andrew and everybody else that's paying attention, I'm going to drop down the function and show you what's inside this function. It's like we're popping the hood. There is the body of the function that's all indented because that's how Python is. And there is that loop that I predicted. But instead of having the number 10 there, or 20, it's a placeholder. It's num. It's like a wild card. It will take on whatever positive number you send to it. That is perfect, efficient coding. Because the 10 controls how many times Seamus watches this for loop circle around. And look at the code inside the for loop. Pen down, draw square, pen up. So a function is calling a function. The function draw many squares, where the squares is plural, calls a function that I wisely named draw square without the S. So that everybody that traces this code can just use good old-fashioned English grammar knowledge of what makes something plural or not. And then I do, I throw in some random numbers. I generate an X variable that's some random whole number, integer, rand integer, between -200 and +200, matching up with the width of my screen on the X-axis. Then I store into some variable Y a random number vertically, and then I plug in that XY and send my turtle to that location, and that's where it draws the next square, which I now have to trace because I'm curious. I'm going to go look at the body of draw square. Oh, draw square has a loop inside of it. This is so complicated. It all started with a call statement that passes a parameter, and then the parameter is caught by the wide receiver here, used as the upper boundary of that for loop, which calls a function, which in turn has a for loop, which has the number 4. And that's what guarantees us good jobs and how to solve the world's crises that are in front of us today. Reusing stuff with loops and functions helps make the productivity of the American and truly international worker much better than it was like 100 years ago and probably even 50 years ago. So good luck tracing the rest of that program and modifying it so that you can hand in a very good advanced drawing project that uses at least 3 functions, which I, by the way, use 3 functions here, but don't totally copy me. 3 or more colors, which I use 3 colors with Braden's help, but don't copy us. And 3 or more loops, but don't just totally copy all of my for loops. Maybe you even want to use a while loop. Okay, have a good day. And let me hear some applause. Okay.